Professor Dr. N. Ganesh is working as a senior faculty, Department of Computer Science and Engineering, SRM University, City Campus, Vadapalani, Chennai. He has more than 12 years of undergraduate and postgraduate teaching experience, which includes 5 years of research experience. He has trained many corporate batches on technologies such as mainframes, Application Systems 400, SAP, ABAP. He has published 10 articles in both international and national journals. He has presented several papers in both national and international conferences. He has written 4 books which are prescribed in Anna University affiliated colleges, SRM University and Bharat University. His research interests are software engineering, data mining and cloud computing.
Welcome to UGC Lecture Series and Computer Science. We are going to see a series of lectures in the subject Operating System. This subject is for the students studying in the 5th semester of the BSc degree program. The subject code is CS0320 of paper number 8. So, in this session, we are going to see certain topics from unit number 1. And in unit number 1, we have many different topics, out of which we are going to see a topic on CPU scheduling and the few CPU schedulers. So this CPU scheduling topic will be handled in 2 different sessions. So we are going to see the first session of this CPU scheduling. So now what are the contents that are available for this session? So we will be seeing the basic concepts of CPU scheduling and what a CPU scheduler is, what is a burst time, what is a IO burst, so on. And then we will be seeing about what is a CPU scheduler and what is a dispatcher, what is a dispatcher latency time and the scheduling criteria, the basic concepts. What is a CPU scheduling? What do you mean by CPU scheduling? See, your scheduling in the sense what it means in a real-time scenario. Schedule. How do you schedule a particular thing? Say for example, if you want to conduct certain interviews, so this particular time the interview is scheduled from 9:30 to 10 o'clock. What does it mean? You have been allocated a time from 9:30 to 10 o'clock. That is your time with the interviewer, and you are said to be the interviewee. So that is the time which has been allocated exclusively for you. Such time is called as a scheduling. So now what is a CPU scheduling? So the CPU here, it is going to allocate certain time frame for the process to get executed. That is called as CPU scheduling. Basically it is allocating time for the processes for execution is called CPU scheduling. So out of which, what is a burst time? A burst time is burst time is classified into 2 different groups. One is called as the CPU burst time, other burst time is the IO burst time. What is the CPU burst time? The time required by the processes to get executed. The time allocated by the CPU for the processes to get executed. You call it as a CPU burst time. What is an IO burst time? An IO burst time is a time that is required for the IO devices to get executed task is called as the IO burst time. So we have 2 different types of burst times. Now we will be seeing about this CPU burst time and IO burst time here. Here in this program we have, this is a set of program. We have taken only a code snippet. What is a code snippet? What do you mean by snippet? A snippet is a part of the code that has been taken from the full length of code. So now we are looking into a code snippet, that is a part of the code. So in which we will be seeing how this part of code gets executed, how the CPU is scheduling the processes involved for its execution, how the CPU is allocating the time both for the program instruction, right, and then for the IO devices to carry out its task. So let us have a look at this snippet. In the snippet, we have there are many different lines over here. Let us see from this line, we have a load store, add store, read from file. So to execute this task, to execute this particular, so each and every line of execution you call it as a thread, and this program execution you call it as a process. So to execute these lines, the time allocated by the CPU is called as the CPU burst time. And now here it stops over here after reading from file. When it stops from that location, because it is not stopping exactly, it is reading some contents from a file. So that particular juncture, your CPU may be pretty free because it is reading from the reading the contents from the text or from the files. So that particular time it can allocate for the IO devices. So the IO devices, IO is nothing but the input output devices. The input output devices gets executed. So the time allocated for executing an input output device, we call it as an IO burst time. So that is given here. It is IO burst time. Then after this IO gets worked out, we again work with the CPU. So we have a store, increment, index, write to file, so on. So likewise the CPU burst time and the IO burst time continues. So now what is a CPU scheduler? How the decisions are being made on the CPU scheduler, which we can see here. In the CPU scheduler, the decisions may take place when a process switches from running to waiting state, or when a process switches from running to ready state, when a process switches from waiting to ready state, or when a process terminates. What is this running to waiting state? What do you mean by waiting to ready state and then termination? I suppose in one of the earlier sessions we have seen about the different process states. What were the different process states that we have seen in that session? The process states is broadly classified into different types. One is a new process state. A new process state is one wherein a new process has been created. Then the second state is said to be the ready state, wherein the process is ready for execution. All the contents of the program get stored in the memory, in the main memory. So which is ready for execution is called as a ready state. The third state is nothing but the running state. The process which gets executed is called as a running state. Then the fourth one is the waiting state. If the process is waiting for some other resource to get freed out, or if some top priority process comes into effect, and if the top priority process gets executed, then this process execution will be interrupted and it will be waiting in a queue till the top priority process completes. So that is called as a waiting state. Then the last state is said to be the termination state. If all the execution gets completed, finished out, and if the process is going to end, if it is going to exit, then such a state you call it as a termination state. So we are linking those process states with the scheduling algorithm, with the scheduling decisions, and that is the reason we are given here as it is switching from running to waiting state, switching from running to ready state, switching from waiting to ready state, and if it terminates. Then the CPU scheduler, we have four different, we have seen all these four different things, out of which the first thing, that is the running to waiting state and the termination state, is called as a non-preemptive states, and the other states are said to be preemptive. What do you mean by non-preemptive and what do you mean by preemptive? I suppose again in one of my earlier sessions, wherein when we saw a topic on deadlocks, we are seeing one of the conditions. There are 4 conditions for a deadlock to happen. What are the 4 conditions? So out of which one condition is said to be non-preemption. So the 4 conditions were mutual exclusion, hold and wait, non-preemption, circular wait. So what is a non-preemption? Non-preemption is even if the other process comes in, if it will not be allowing the other process to, it will not mind the entry of the other process. So this will be doing the work and this will be completing the entire process. So such a criteria you call it as a non-preemption or no preemption. So this first point and the fourth point is of the non-preemption type, whereas the second point and the third point or the other points is of the preemptive types. So that is about the CPU scheduler. Then let us move on to the next concept called dispatcher. What do you mean by dispatcher? Who is a dispatcher in real time? You say, for example, you go to a post office wherein you post your mails, you post your letters, and there will be a particular person, the postal employee. He will be segregating all the mails based on the different locations. Say, for example, if you have been put up, he will be segregating certain mails that is relevant to Tamil Nadu, that is relevant to Kerala, that is relevant to Andhra Pradesh, that is relevant to Delhi, that is relevant to Assam, so on and so forth. So, and based on those segregation, there will be a dispatcher to take all those mails and to dispatch it to each and every individual concerned. He will be giving it to each and every addresses concerned. So that is a real-time scenario. So let us relate this with respect to a operating system. In the operating system, we have a dispatcher wherein even this segregates. It will be seeing this particular process, how to allocate the time frame. So supposing if one particular process is going to get completed, so if there is a process waiting in queue, so that particular slot will be allocated to a process which is waiting in queue. So the scheduling algorithm which allocates the process which is to a time region which is pretty free is called as a dispatcher. Now, what is a dispatcher latency time? A dispatcher latency time has been given like this. A dispatcher is one which is used for a switching context. It is switching to user mode. It is jumping to a proper location in the user program to restart that program. A dispatcher latency time takes the dispatcher to stop one process and start the other process which is running. That is called as a dispatcher. Now, the next topic is on the scheduling criteria. What are the criteria that is required for scheduling? We have a CPU utilization. One of the criteria is to be CPU utilization. Second criteria is to be throughput. Third criteria is to be turnaround time. What is a CPU utilization? CPU utilization is, what do you mean by utilization in real terms? And utilization is one wherein you make yourself busy. You are utilizing a resource completely. Even here, CPU utilization is this particular CPU is being kept fully busy for the entire time frame. That is called as CPU utilization. The next one is to be the throughput. What is a throughput? The number of processes that complete their execution per unit time is called as a throughput. Then what is a turnaround time? Amount of time that is required to execute a particular process, you call it as a turnaround time. Then what are the other scheduling algorithms, scheduling criteria you have? One is the waiting time, other one is to be the response time. What is a waiting time? A waiting time is the amount of time a process has to be waiting in the ready queue. Then what is a response time? Amount of time it takes from when a request was submitted until the first response is produced, not the output. That is, here in a waiting time, the process is waiting for the process to get executed. As far as the response time is concerned, there is a time taken from the first response to this period is called as a response time. So this is how CPU scheduling, these are the criterions required for scheduling a CPU. What is CPU? Central Processing Unit. So the CPU optimization scheduling criteria, let us see after a short break. Welcome back after the break. We were seeing the CPU scheduling criteria that are required to schedule a particular time frame for the process execution. So what are things that are required? Let us see now. We require the following points. First, maximum CPU utilization. Second, maximum throughput. Third, minimum turnaround time. Fourth, minimum waiting time. Fifth, minimum response time. So these are the 5 points that are required to schedule an algorithm, to schedule an optimization algorithm. Now let us move on to the next topic, the important topic and an interesting topic. What are the different algorithms that are available as far as the CPU scheduling is concerned? We have 4 different types of algorithm. One is called as first come first served algorithm, which is nothing but which is shortly called as FCFS algorithm. The second algorithm is called as the shortest job first algorithm, which is nothing but SJF algorithm. The third algorithm is called as the priority scheduling, wherein we do not have any sort of shortened forms. The fourth algorithm is called as round robin algorithm. Round robin, again it is shortly called as RR algorithm. So let us now see the FCFS algorithm, which is nothing but the first come first served algorithm. In the first come first served algorithm, what do you mean by the term first come first served? By the term first come first served, it means if you go first, you will be served first. Say for example, let us consider you are standing in a queue, you are waiting to have your breakfast, wherein you have your plates with you, and you take your plates. Whoever stands in the queue with their plates, whoever comes first will be given first priority and they will be served first. So they will be served. So that is called as a first come and first served basis. So similarly, let us relate this example with the operating system CPU scheduling concept. This first come first served algorithm, let us look at a small problem. So let us consider there are 3 different processes. One is process P1, second one is process P2, third one is process P3. So the burst time is 24, 3 for process P2, 3 for P3. What is the burst time? The time taken for this particular process to get completed, to get executed fully is called as a burst time. Say for example, this process P1 has taken 24 milliseconds to complete this process, and P2 takes 3 milliseconds to complete the process. P3 takes 3 milliseconds to complete the process. Now, how it has been assigned? So, this P1 comes first, P2 comes second, P3 comes third. So, this is said to be my space. So, here there is no waiting time for P1. So, it enters immediately, wherein it takes 24 milliseconds to complete this particular process. So, this 24 has been written over here, and this P2 takes 3 milliseconds to complete this. Already CPU has scheduled 24 milliseconds for this process P1. So for this process P2, since it takes 3 milliseconds to complete, it should wait for 24 milliseconds for the first process to get completed. Until that, this P2 will be in queue. Then P2 will be given 3 milliseconds. So 24 plus 3 becomes 27. And this process P3 again, it takes 3 milliseconds. So till process P1 and P2 gets completed, this P3 has to wait in queue. Say for example, this guy is standing in the third person when compared to these two guys. So until these two people are being served, this person has to wait in the queue. So after 27, it takes 3 milliseconds. So 27 plus 3 becomes 30. I suppose you might be clear how you got this graph. So what will be, if this is the case, what will be the average waiting time and what will be the waiting time for each and every process? Here, this process P1, before this process P1, there is no other process. So which means there is no waiting time for this process P1. So the waiting time of process P1 is 0 milliseconds, and for this process P2, in order to get executed, it needs to wait for 24 milliseconds. So after 24th millisecond only it can get executed. So this process P3, it has to wait for 27 milliseconds. Why? Because 24 milliseconds has been taken by P1, 3 milliseconds has been taken by P2, that is 27. 24 plus 3 becomes 27. So this process P3 has to wait for 27 milliseconds. And in order to complete this process P3, it requires 30 milliseconds. So after, supposing if you have further processes, it has to go only after this 30 milliseconds. So that is said to be my waiting time of each and every process. Now let us find the average waiting time of each and every process. Here it is. As far as the average waiting time is concerned, the process P1, there is no waiting time at all, so it is 0. Process P2 is waiting for 24 milliseconds. Process P3 was waiting for 27 milliseconds. So, average means this thing, the total divided by the total number of processes. There are 3 different processes, so the total is 0 plus 24 plus 27 divided by 3, whole divided by 3, because there are 3 processes. So 24 plus 27 by 3 becomes 17. So the average waiting time that happened for each and every process is said to be 17 milliseconds. Now let us see a different example. Here we will interchange the process and we will make the other process to go on the first come basis, and then we will make the process P1 to execute at the last, and then let us find out what will be the average waiting time for each process, and then we will say which is far better, whether the first approach is better or the second approach is better. Now here again, in this the same old example, let us consider we are changing an order that P2, process P2 gets executed first, process P3 gets executed first, and then process P1. So in this case what happens? So before process P2 there is no other process, so the waiting time for process P2 is 0. So the time taken for execution of this particular process is 3 milliseconds, as we have seen over here. Compare it with this table. So P1 24, P2 3, P3 3. So here it takes 3 milliseconds, and this process P3, it again takes 3 milliseconds. So 3 plus 3 becomes 6. So the remaining 24 milliseconds is required for the process P1 to get completed. So 6 plus 24 becomes 30. Now let us calculate the average waiting time. What is the average waiting time? It is 0. So for process P1, what is the average waiting time of process P1? The waiting time of P1 is, it was waiting for 6 milliseconds. So 6 plus what is the waiting time of P2? It is 0. 6 plus 0, what is the waiting time of P3? It is 3. So 6 plus 0 plus 3 divided by 3. What do you get? 3. So what was the previous case? In your previous case, you had the average waiting time as 17 milliseconds for a process to get completed. Here we have only within 3 milliseconds we are able to complete. The average waiting time of each process is only 3 milliseconds. So this approach is much faster when compared to the previous approach. Even here it is coming first come first served, even over there it is first come first served, but which process to be served first matters a lot. So this is more weightage when compared to the other process. So this is as well called as a convoy effect. Convoy effect is nothing but shortest process behind long process. So this effect we call it as a convoy effect. Then the next, let us now move on to a next algorithm called as the shortest job first algorithm. What do you mean by shortest job first algorithm? In the earlier case, we are saying first come first served algorithm. Whichever process comes first, that will be served first. But we saw a convoy effect wherein the shortest job, when you are going to send it first, your average waiting time of the other process remains comparatively less, and then it is a much better algorithm. It is a better algorithm compared to sending a long process at the start. Now let us move on to second algorithm called as shortest job first algorithm, which is also called as an SJF algorithm. As the name implies, what do you mean by this? Shortest job first. Whichever process has the shortest burst time, we call it as a shortest job first. Whichever job gets executed within a short period of time, we call it as a shortest job. So we are placing that job at the first, and then we are trying to execute, and we are trying to find the average waiting time of each and every process. So here is an example. Let us consider there are 3 different processes, P1, P2, P3 and P4. So let us consider the interval time of each process is said to be, so these are said to be certain process arrays. So let us consider the interval time, because we are much worried about the process name and its interval time, not the other segments. So the interval time over here is process P1 takes the time to complete 6 milliseconds to complete this process. P2 takes 8 milliseconds. P3 takes 7 milliseconds. P4 takes 3 milliseconds. Out of these 4 processes, can you identify and let us know which is said to be the minimum process time required for completion? It is 3 milliseconds is said to be the minimum time required for completion. So here what we will do is we will put this P4, process P4 over here. So the waiting time of P4 is 0 because this is said to be the shortest time within a very short span of time this has got completed. So the initial waiting time of P4 is 0. So what is the time taken for completing this P4? It is only 3 milliseconds. So we are going to put it as 0 and it is 3 because it has taken 3 milliseconds to complete. Then what is the next minimum over here? It is 6 milliseconds. So after P4, P1 gets executed. So after 3, it takes 6 milliseconds to complete. So 3 plus 6 becomes 9. So after P1, after 6, which is said to be the next shortest, 7 is said to be the next shortest. 7 relates to which process number? P3. So here after P1, P3 comes into picture. So it takes 7 milliseconds to complete. So 9 plus 7 becomes 16. So after P3, we have been left out with one other process which takes 8 milliseconds to complete. That is called process P2. So 16 plus 8 becomes 24. Now let us calculate the average waiting time. Average waiting time is, since process P4 does not have any sort of waiting time, it takes 3 plus 16 because P1, from P1 let us consider the average waiting time. P1 takes 3 milliseconds to complete. So 3. P2 takes 16 milliseconds to complete. 3 plus 16. P3 takes 9 milliseconds to start. P1 takes 3 milliseconds to start. P2 takes 16 milliseconds to start. P3 takes 9 milliseconds to start. P4 takes 0 milliseconds to start. So 3 plus 16 plus 9 plus 0 divided by 4. Why 4? Because there are 4 number of processes divided by the total number of processes. When you add and divide it by 4, you get a value of 7. So that is an example for this shortest job first. Now based on the approach, we can schedule the algorithm. We can use the algorithm either as the first come first served or as the shortest job first algorithm. Now let us summarize the topics that we have seen in this session. So we have seen basic concepts of CPU scheduling. We have seen what a CPU scheduling is, what is a burst time is, what is an IO burst time, what do you mean by a CPU burst time. We have as well discussed about the different CPU scheduler algorithms. So there are 4 different algorithms, out of which we have seen 2 different algorithms now. One is the first come first served, other one is said to be the shortest job first. The remaining 2 algorithms we will be seeing in the forthcoming lecture. Then we have seen about what a dispatcher is and we have seen the criteria for scheduling. Now let us see what are the possible questions that can come from this particular session. The questions are, question number 1, it is what is the CPU burst time? What is IO burst time? How FCFS is first come first served approach works. How the shortest job first approach works. What is a dispatcher? What is the criteria for scheduling an algorithm? So these are the possible questions that can be framed from this session. So with this we come to an end of this session. We will be seeing more topics about operating system in the forthcoming lectures.